This is the video review guide for Unit 3, Periodic Table, Periodic Trends. Okay, we're going to start out here with some identifying number of valence electrons and Lewis dot structures. So for the first one, phosphorus, notice phosphorus is in group 15. That means that it has 5 valence electrons. When you draw it, start here, right, top, left, bottom, fifth one you pair up. Neon is in group 18. That means it has 8 valence electrons. Ne, 1, 2, 3, 4. Pair them up. 5, 6, 7, 8. 2 on each side. Beryllium is in group 2. That means it has 2 valence electrons. I'd like it to look like this. One on the right, one on the top. Fluorine is in group 17. It has 7. 1, 2, 3, 4, 5, 6, 7. So 2 on each side, 1 on the bottom. And then potassium is in group 1. It has 1. Should look like that. These next two questions deal with a lab we did not do. This was a flame test lab. Basically, how you move electrons from one atom, from one energy level to another, you add energy. Okay, you're not going to have this question on the exam because we didn't do the activity. Why do they emit different colors of light? And once again, you won't have this question because we didn't do it, but because each element has a unique arrangement of electrons. How is the modern periodic table arranged? Many ways you could answer this. You could say in groups and periods. Okay. You could also say this. You could give them. You could say like metals are found over here to the left. Non-metals are found here to the right. And touching that line are the metalloids. Okay. All kinds of things, but these are probably the most common answers. You could say in order of increasing atomic number. Okay. Many answers are correct for this one. Number 5, which of these elements have similar chemical and physical properties? That's going to be B. Strontium, magnesium, calcium, and beryllium. If you look at your periodic table, you'll notice they're all in group 2, which means they have the same number of valence electrons. Metal, non-metal, or metalloid here. Gold. Gold is a metal that is found to the left of the stair step. Silicon is right on the stairs, so it's a metalloid. Okay, sulfur. Sulfur is found to the right of the stairs. That means that is a non-metal. And then barium. Barium is found to the left of the stairs. That is a metal. Okay, and then looking at properties of metals and nonmetals, a gas at room temperature, that's generally going to be a non-metal. Brittle, once again, that means you hit it with a hammer, it fractures, that's also non-metal. Malleable, which means bendy, or you can shape it, that's metallic, that's a metal. Poor conductor of heat and electricity, that's a non-metal. And then shiny, that's typically going to be a metal. All right. And then if you have a substance that has a combination of those properties, it's generally going to be a metalloid. Okay, has some properties of metals, some properties of nonmetals. Two elements that have properties similar to that of sodium, any of these would work. Lithium, potassium, rubidium, cesium, francium, any of those. Okay, they've got to be ones in the same group. Those are all alkali metals. They all have one valence electron. Arrange these orders in order of decreasing atomic size. So this means from the largest to the smallest. And so looking at these are all going to be elements of the third period. So the biggest one is going to be the one furthest to the left, which is sodium. Okay, the next one you're going to come across is going to be aluminum, followed by sulfur, And then the smallest of those is going to be chlorine. Okay, remember as you go across left to right, atoms get smaller. Which of these elements has the highest radius? Okay, sodium and lithium, it's sodium. Why? It has one more energy level. Strontium and magnesium, it's going to be strontium because it has two more energy levels. It's in the fifth period, and magnesium's only in the third. So strontium has 5 rings, magnesium has 3. Germanium is further down, more rings. Selenium or oxygen, selenium. Which of the following has the greater first ionization energy? And so you have to recall first ionization energy is an atom's or the amount of energy it takes to strip an electron away from an atom. So let's see. We have lithium and we have boron. It's going to take more energy to strip one from boron. Remember, it increases as you go across because you're getting closer to that octet, more protons, all that jazz. Magnesium or strontium. Magnesium, because they're closer to the nucleus. Much easier to grab a valence electron from strontium because it has more rings, it's further away. There's increased electron shielding. Cesium or aluminum. Cesium. Not only does it have more rings, it has fewer valence electrons. This one we're looking at electronegativity. Recall electronegativity is an atom's attraction for a shared pair of electrons. The general rule of thumb is the closer an electron is to fluorine on the periodic table, the more electronegative it's going to be. Fluorine is by far the most electronegative element, so it is going to be the more electronegative one. Carbon or nitrogen? Nitrogen. Magnesium or neon? This is the only one that's maybe slightly tricky. Okay, it's going to be magnesium. Even though neon sits right next to fluorine, neon has its perfect collection, its perfect 8. It has 8 valence electrons. It doesn't want to attract anymore. Okay, arsenic or calcium? That would be arsenic. Okay, which elements? Which one has a greater attraction? That's the same thing. Same thing as electronegativity. So oxygen. Once again, closer to fluorine. Fluorine is the most electronegative, so it's got to be that. Oxygen is right next door, so it's got to be that one, and then sulfur. Okay, common names for groups 1, 2, 17, and 18. 1. Alkali metals. 2. Alkaline earth metals. 17. These are called the halogens. And then group 18 are the noble gases.